Hello friends, welcome to Stuff Networks. This is part 2 of our OSPF video. If you haven't watched part 1 yet, go check it out. The link is in the description. So without wasting any time, we will continue and learn about OSPF. Let's take a quick revision of our previous video. OSPF is a link state routing protocol that uses cost as its metric, calculated as reference bandwidth divided by interface bandwidth to find the best path via the Dijkstra algorithm. It uses 5 message types: hello, DBD, LSR, LSU, LSX. To maintain neighbor relationship and share topology information, OSPF supports various network types such as broadcast and point-to-point and uses timers to manage neighbor agencies and database synchronization. Let's start with a new topic: types of OSPF. In OSPF, open shortest path first. Routers are classified into 4 main types based on their location and function within the OSPF network. Internal router, which are within a single OSPF area. Backbone router, which have at least one interface in backbone area, area 0. Area border routers, ABRs, which connect different areas, and the backbone and autonomous system boundary routers, ASBRs, which connect the OSPF domain to external network or protocols. So let me explain you about routers. Internal router. An internal router has all its interface within the same OSPF area. It maintains only one link state database, LSDB, for its single area. Second is backbone router. This is any router that has at least one interface connected to backbone area, area 0. ABRs are always classified as backbone routers because they connected to area 0. Area border router. An ABR has interfaces in the backbone area and at least one interface in non-backbone area. It summarizes routing information, LSAs, from different areas and advertises them to other areas, maintaining a separate LSDB for each area it connects. Router. Fourth is autonomous system boundary. An ASBR connects to the OSPF domain and to the network outside the OSPF domain, such as another OSPF domain, a legacy routing protocol like RIP or EIGRP, or directly connected static routes. It performs routes redistribution, injection, external routes into the OSPF domain, and advertising them using the external LSAs. Our next topic is types of LSA. Link state advertisement. OSPF link state advertisements, LSAs, are packets used to exchange routing information. The main types are type 1 router LSA, describing a router link with its area. Type 2 network LSA, describing multi-access networks on a designated routers. Type 3 summary LSA, sent by area border routers, ABRs, to advertise inter-area routers. Type 4 ASBR summary LSA, also from ABRs, to guide router to an autonomous system boundary router. And type 5 is external LSA, which is generated by ABRs to advertise routes from external routing protocol. Type 7 NSSA external router is a special case of not so stubby areas, NSSA. LSA type 1 network LSA. An LSA type 1 router LSA is a link state advertisement that an OSPF router creates to describe its own status and interfaces. It is flooded to all other routers within the same OSPF area and contains information like the router ID, connected links, IP addresses, subnet mask, and the cost of each link. Routers use type 1 LSA to build topology map of their local area. LSA type 2 network LSA. Purpose: advertises multi-access network segments like Ethernet and generated by the designated router DR on that segment. Flooding: flooded to all routers within the same area, ensuring they have an accurate view of network topology. Information: includes information about the DR and backup designated router BDR for the segment, as well as IP addresses and subnet information for all routers connected to the network. LSA type 3 summary LSA. Purpose: used to advertise routes between different OSPF areas. Generation: generated by area border routers, ABRs, that connect different OSPF areas. Information: contains summarized route information from one area which is then sent to other areas to allow inter-area routing. LSA Type 4 ASBR Summary LSA Purpose informs router in an area about the location of an autonomous system boundary router ASBR. Generation generated by an ABR. Information it provides information for other routers to find the ASBR which is necessary for router traffic in external router. LSA Type 5 External LSA Purpose advertises routes that have been imported or redistributed into the OSPF domain from an external routing protocol or source. Generation generated by ASBR. Flooding flooded throughout the entire OSPF domain, all areas. Type 6 Group Membership LSAs. Purpose Type 6 LSAs were created to inform routers about the membership of multicast group, enabling multicast routing within a OSPF domain. Status The protocol extension for multicast was complex and was never widely implemented or deployed. Current standard Protocol independent multicast PM in the standard protocol for IP multicast today. Vendor support Major vendors including Cisco do not support or use Type 6 LSAs for multicast routing. Legacy reference It is sometimes mentioned for the completeness when discussing the history of OSPF LSAs types, but it is not practical feature to configure or understand the modern network designs. LSA Type 7 NSSA External LSA Purpose A specialized LSA used in not so stubby areas NSSA to advertise external routes without flooding Type 5 LSAs which are restricted in stubby areas. Generation generated by an ASBR within an SSA. Conversion An ABR then converts the Type 7 LSA into a Type 5 LSA before sending it into rest of OSPF domain. Difference between DER and BDR. DR designated router act as the central point of exchanging OSPF routing updates on a segment elected based on highest OSPF priority or in case of the highest router ID forms a full agency with other routers on the segment receives routing updates from all other routers and then floods them to the rest of the network generates type 2 link state advertisements LSAs to describe the segment. Only elected on multi-access network types such as Ethernet LANs. BDR Backup Designated Router stands by as a backup and takes over the DR's role if it fails. Elected based on the second half highest OSPF priority or in case of a tie, the second highest router ID. Forms a full agencies with all other routers on the segment just like the DR. Does not actively disseminate routing updates but listens and ready to take over if needed. Does not generate type 2 LSAs, only elected and multi-access network types. Today's last topic is OSPF configuration and troubleshooting. Open Shortest Path First OSPF is a link state routing protocol used to find best path for packet delivery in autonomous system. It is well suited for large complex enterprise networks because it is scalability and rapid convergence. Basic OSPF configuration. Basic setup involves enabling OSPF during a writer ID and configuring interfaces to participate in the OSPF process. Router ID selection. A unique router ID RID identifies each router in the OSPF domain. A router chooses RID based on the following order of precedence. Manual configuration. The administrator specifies the RID using the router ID command. This is recommended and most scalable approach. Highest loopback IP address. If no router ID is configured, the router selects the highest IP of any active loopback interface. Highest physical interface IP address. If no loopback interfaces are configured, the router chooses the highest IP address of any active physical interface. Troubleshooting OSPF. When troubleshooting OSPF, you should perform a basic sanity check and then systematically inspect common issues that prevent neighbor agencies or route advertisement. Troubleshooting neighbor agencies. OSPF neighbors must satisfy several conditions To form an agency, a mismatch of any of the following parameter will cause a failure. Area ID must match on all routers on a shared segment. Subnet mask must match on all routers on a shared segment. Hello and dead timers must match on all neighbors on a shared segment. The default hello interval is 10 seconds of broadcast and point-to-point links, and the dead interval is 40 seconds. Authentication. Passwords and authentication type must match on all routers on a shared segment. OSPF network type must be compatible for neighbor to form agencies. MTU mismatch. An MTU mismatch can cause routers to stuck in extract or exchange state. Duplicate router ID. If two routers have the same router ID, they will not form an agency. Troubleshooting route advertisement. If neighbors are up but routes are missing, consider the following. Filtering. Check for any configured router filters such as distribute list of area ranges that might block routes. Network statements. Ensure the network commands or per interface OSPF configuration are correct and cover the intended subnets. Summarization. Improper route summarization on an area border router ABR can block more specific routes from being advertised into other areas. Redistribution. If routes are being redistributed from another protocol, ensure the redistribution is configured correctly and check for route tagging issue. These are some show and debug commands. Write it in your notebook or take a screenshot. Now I will show you how to configure IP address and OSPF. To configure OSPF, first I will take two routers. Now I will put two PCs here. One PC in here and second PC here. Now we have to give it a connection. So I am using a simple copper wire. So I have connected both of the routers and both of the PCs with each other. So now I will give them a IP. So first I will write down here. So as you can see, I have given them IPs to both of my routers and both of my PCs. So now I will configure it fully. To configure it, here I am in the PC 0 and I will go to desktop IP configuration. Here we have to write our IP. So I have given IP to my PC 0 is 192.168.1.2. So I will write it here. Now I have to write a default gateway IP address. The IP I have given to my router, I will write it here. That is 192.168.1.3. So I have configured the IP of PC0. So same I will do like this to my PC1. So here I will go to desktop IP configuration and write my IP here. I have given it IP 192.168.2.2. Now I will give it a default gateway IP. The default gateway IP is 192.168.2.3. So I have configured the IP of both of my PCs. So now I have to configure the IP of my routers. So to configure the router ID, here is my router 0. I will first turn it off and I am using the module NM8AS. I will fit it here first. So as you can see, I have fitted it and now I will turn it on. Now I will go to CLI. So you can see it was working. Here we have to write no. So I will write here no and enter. Once again enter. Here we have to give the command of enable. And now we will write configure terminal. Enter. And here I will write interface FA0/0. So after these commands, we have to finally configure the IP. To configure the IP, we will write here IP address and give the IP of my router. So I will write IP address 192.168.1.2 because this is my router 0. And also we will write subnet mask 255.255.255.0. And after pressing enter, we have to write here no shutdown to make the interface up. So as you can see, we have configured the IP of our FA00. So now we'll configure the IP of FA01. Same commands we will use like interface FA01, enter IP address 192.168.13.2 because I have given the 3.2 IP to the FA01. So now our both of the interface are up. So now we will also configure the OSPF, and to configure the OSPF we have to write router OSPF. I will write here router OSPF, and I will give it a one value. And now here we will write network and the IP of our PC 0. So we will write network 192.168.1.2 and also write our wildcard mask, which is the opposite of subnet mask. So subnet mask is like 255.255.255.0 and wildcard mask is like 0.0.0.255. And after writing IP address and our wildcard mask, we will write area 0. So now I have to give it a IP of my FA01. So I will write here network 192.168.3.2 because this is the IP of my FA01 interface. Now I will finish my work by giving the exit command. So I will write here exit. Again I will write here exit to fully exit it. Now I will save my command by typing WR. As you can see, we have configured the IP and OSPF in our router 0. So now we will configure the IP and OSPF in our router 1. So we will do all the process same. We will turn it off and add one module here. And again we will go to CLI. Sorry, I forgot to turn it on. So we will first turn it on and go to CLI. You can see it was working. So again I will write no and enable command here. And here I will write configure terminal. All the commands are same, nothing is changed. Configure terminal. And here I have to write interface FA01, sorry 00. So now here I will give the IP address of a router. The IP of a router is here I will write IP address 192.168.2.3. This is the IP of our router 1. So after writing the IP, I will also write the subnet mask 255.255.255.0 and press enter. So again I will write here no shutdown to make the interface up. Yes. So now I have to configure the IP of our router, or our interface FA01. So same process I will do. Of my interface 01 IP is now 192.168.3.2. Oh, sorry, 3.3. So now I will configure OSPF. And in 0 my router 0 I have given it value 1, so here I will give it value 2. To again configure OSPF in my router 1, I will write same command here network 192.168.2.2 because this is the IP of my PC 1 which is connected to router 1. And so we will also give the wildcard mask here 0.0.0.255 and area 0. And again I will write same commands here, network 192.168.3.3, because this is the IP of my FA01. And again the wildcard mask is 0.0.0.255 and area 0. And again I will give same commands which I have given there, exit enter, exit enter, and to save my all the commands I will write WR. I have configured the OSPF and IP address. So I have created an green color area here which is named as area 0. So this is our diagram in which we have configured our IP address and OSPF. So you can also see the successful it is coming. I am sending packets there, so it was successful. Every time I will send the packets, it will get successful, which means our PC and routers are connected properly and OSPF is also configured properly. Now I will tell you how to verify OSPF. To verify OSPF, first command is show IP protocol. It provides general information about all routing protocols running on the router, including the OSPF process ID, router ID, networks it's routing for, and neighbor information sources. Second command is show IP OSPF neighbor. Show IP OSPF neighbor display a list of all OSPF neighbors and their current state. The state should be full for stable adjacencies unless it's a point-to-point link where it might show a dash. This is the most crucial verification command. Third command we use is show IP OSPF interface. Show IP OSPF interface type, interface number. Shows OSPF related information for a specific interface or all interfaces, including the area it belongs to, network type, host, and hello dead time intervals. Our fourth command is show IP route. Show IP route displays the router's full IP routing table, OSPF learned routes and marked with an 0. You can filter this just OSPF routes which show IP route OSPF. Advanced verification commands, command description. Our fifth command is show IP OSPF. Show IP OSPF displays detailed information about the OSPF routing process, such as the router ID, the number of areas configured, and SPF calculation timers. Show IP OSPF database displays the OSPF link state database, which contains the link state advertisement LSAs for that area. This is useful for advanced troubleshooting. Our last command is show IP OSPF border. Display information about routes to area border routes and autonomous system boundary routers. These are the commands I have used to configure IP and OSPF in my router 0 and router 1. You can write it in your notebook or take a screenshot. Thanks for watching. If you found this video helpful, don't forget to like, share and subscribe, and also press the bell icon for future updates.